Hello students, welcome to 10th problem on system of particles and rotational motion. A uniform pole of mass 20 kg and length 6 meter is suspended horizontally on two knife edges A and B at the ends. If a mass of 120 kg is now suspended at a distance of 2 meters from A, calculate the reaction on the knife edges. So we want to calculate the reaction force on the knife edges. So let us take a uniform pole of mass 20 kg and a length of 6 meters. So this is a uniform pole of mass 20 kg and it has a length of 6 meters. If I mark the pole one end as A and other end as B, then AB length is 6 meters. And this pole has a weight of 20 kg. Of course, they have given its mass 20 kg and we can take that as 20 kg weight, which is the weight of the pole. So, they have given mass and we can write that in terms of kg weight because it is a force. Weight is a force. We know that the entire mass of this pole is acting at the geometric center of the pole. So therefore, this is the weight which is acting vertically downward of this pole, which is the center of the pole, and I marked it as C. So which is W equal to 20 kg weight. And this pole is suspended with the help of two knife edges. This is one knife edges and this other knife edges. The entire pole is suspended with the help of two knife edges which are placed one at A and other at B. After that, another weight of 120 kg weight which is again suspended to this pole, which is at a distance say 2 meters from the end A. It is what they have given in the problem. If a mass of 120 kg is now suspended at a distance of 2 meters from A. Now a mass of 120 kg is suspended at a distance 2 meters from A end of the knife edges. Say this is the point D. And of course this is also a weight, so I have taken that as 120 kg weight. So 120 kg weight is the weight suspended at a distance of 2 meters from knife edge A, which is one end of the pole. What they are asked in the problem is, we want the reaction on the knife edges. For every action there is an equal and opposite reaction according to Newton's third law of motion. And at point A and at point B, these two knife edges will have a reaction force, and I have marked that as R1, which is the reaction force on this knife edge which is placed at A, and R2 is the reaction force on the knife edges which is placed at B. So we want to know what is the value of R1 and R2, which are the reaction forces acting on the knife edges at A and at B. So I will take that R1 and R2 are the reaction forces. Are the reaction forces. Reaction forces at A and B respectively. That R1 and R2 are the reaction forces at A and B respectively. Since the pole remains in horizontal. What is the condition? In order to keep this pole under horizontal, the condition is sum of the upward forces acting on this pole should be equal to sum of the downward forces. What are the downward forces acting on this pole? Which is P, that is one force which is acting at a point D, and another is the weight of the pole which is acting at a point C. These two are called as downward forces. And what are the upward forces acting on the pole? That is R1 and R2. When the sum of these upward forces is equal to sum of the downward forces, then the pole remains horizontal. Right, that condition. Since pole is at equilibrium, sum of the upward force is equal to sum of the downward force. What is the condition? Sum of the upward force equal to sum of the downward force. So that is R1 plus R2. Sum of the upward force is R1 plus R2. This should be equal to sum of the downward forces, that is P plus W. These two are the downward forces. So we can write R1 plus R2. This will be equal to, I know the P value. P value is 120 kg weight. 120 plus W is 20 kg weight, therefore it is 140 kg weight. So I will call this as equation 1 because later I will use this equation to find the value of R1. So here I got sum of the upward force R1 plus R2 is equal to sum of the downward force, that is 120 plus 20, which is 140. So now let us take the moment of force about A of this pole which is suspended between two knife edges. See, according to equilibrium condition, we know that sum of the anti-clockwise movements will be equal to sum of the clockwise movements. So that we write. Total anti-clockwise movements is should be equal to total clockwise movements. Total anti-clockwise movements is equal to total clockwise movements. Now, taking movements about A. So now I will take movement of force about the point A. If I take the movement of force about A, so I will take this point, this is A. I want the movement of force about the point A. At this point we have R1 upward force, that is R1 into moment of force means force into perpendicular distance. Since I am taking movements at the point A, perpendicular distance is 0. Yeah, R1 into 0, then plus R2 into R2 is this force into perpendicular distance from these 2 points, that is R2 into AB here. R2 into AB, and this should be equal to this force P into this distance. P into distance means AD here, plus W into this distance AC. W into AC. So this term becomes 0 here. R2 into AB. AB is 6 meter. Therefore, we write 6 R2. That is what I left in the ledger side. It should be equal to P force into distance AD. P force is 120 kg by degrees into AD means this distance. AD is equal to 2 meter into 2 plus W, that is the weight of the pole, which is 20 into this distance. That is AC. AC is 3 meter of the length of the pole, that is 3 meter. That is 6 R2 is equal to, it is 240 plus 60 degrees. So 240 plus 60, that is R2 is equal to 300 divided by 6 inches, which is equal to 50 kg weight. So I got one of the reaction force R2 as 50 kg weight. So this R2 has 50 kg weight, that is reaction force. Again now I want to put that in equation 1 to get the value of R1. So which means R1 plus 50, it should be equal to 140, or R1 is equal to 140 minus 50. 140 minus 50 is 90 kg. So we got both the reaction force. R1 is 50 kg weight and R2 is R2 is 50 kg weight and R1 is 90 kg weight. So this reaction force has R1 has 90 kg weight and this reaction force R2 has 50 kg weight. This R1 reaction force has more value because this 120 kg of mass is suspended very close to the point A where we have reaction force R1. Thus R1 is greater than R2 in this case. If you shift this 120 kg to the other side, that is far side of this A, that is close to B, then R2 is greater than R1. So we have got both the R1 and R2 value, which is R2 has 50 kg weight and R1 has